Hello friends, welcome to my channel, myself Parag Jambulkar. In this video, we will see multi-threading in C++ programming language by using OpenMP API. So first thing that we will see, what is thread? So look at this. First thing that we have, that is program. So see, if I ask, you have to write one program for addition of two arrays, something like that. So see, some collection of statements, valid statements, it becomes a program, right? If we compile that program, then we get object file or executable file, right? So see, this program is saved in our secondary storage, maybe hard disk or USB drive. Now see, when we run that program, it becomes a process. So see, another thing is process. So when we run that program, when we run that executable file which is saved in our secondary storage, it becomes a process. So when we are running that, so that secondary storage program is taken to our primary memory, that is our RAM. Processor is taking code from the RAM and it is executing that, right? So program, when we run that, it becomes a process. Now see, suppose we have one process for addition of two arrays or two numbers. We will call it process 1. Now see, suppose we have another program and that also we are running it. Suppose subtraction of two numbers, then we will get another process. Or another example, see, this Chrome as one process, Word as another process, like this. So we can have multiple processes running in our computer at the same time, right? Okay. Now see, every process has its own memory space. Another process, it will have another memory space, right? So every process has its own memory space. Now see, we have one more concept that is called a thread. So look at this. Now what is the meaning of thread and why it is required? So see, thread is a part of any process. It is sub part of any process. Why we require? So see, suppose we have one process. It will take some time, right? It will take some time to execute. What we can do? We can divide that process into multiple threads. So see, we can divide this process into multiple threads. Something like this. Why we will divide it? So see, nowadays whatever the processor that we have, those follows multi-core architecture. Multi-core architecture. When we run any process, so it will use only one core, right? But we have multi-core architecture. So what we can do, we can divide that process into multiple threads. We will allocate some task to that multiple threads and those multiple threads will run simultaneously on multiple cores. As those multiple threads are running simultaneously or concurrently, that multiple tasks will be done in less time. Alright. So what we are doing, we are dividing that process into multiple tasks. We are allocating those multiple tasks to multiple threads. That multiple threads will run parallelly, simultaneously on multiple cores. So what is thread? It is smallest unit of execution within a process. So actually it is a part of any process. Now see, multiple threads share the same memory as that of parent process. What is the meaning of this? See, within one process, we are creating multiple threads, right? All these threads will share the same memory as that of parent process. But see, if we create another process, so it will have another memory. It will take another memory, right? So see, process 1 will have some memory. Process 2 will have another memory. Process 3 will have some another memory, right? So every process takes its own address space, takes its own memory, right? But when we are creating multiple threads in any process, so all those threads, they share same memory space of the parent process. So if any process, if we are creating multiple threads, so those threads will share same memory space as that of parent process. And because of that, these threads are called as lightweight. Lightweight means they consume lesser resources. So look at this. Thread is the smallest unit of execution within a process. They share same memory space as that of parent process. Threads are called as lightweight processes. Why? Because they consume lesser resources. Now see, to create multiple threads, we can use OpenMP API. Nowadays in C++ newer version, they have inbuilt support for the threads. But we can also create thread by using another OpenMP library. So in this video, we will see how to use OpenMP library or OpenMP API to create multiple threads. So look at this. So see, what is full form? Open Multiprocessing. This OpenMP stands for Open Multiprocessing. What is the meaning of this open? Open means open source. This is open source API or open source library. And as we can create multiple threads, it is said that multiprocessing. Now see, when we got OpenMP, so OpenMP got launched in 1997, and in the beginning it was launched for the Fortran language, and in next year in 1998 it got support for the C++ language. Who is managing this OpenMP? So see, there is one organization, OpenMP Architecture Review Board. This organization is a consortium of multiple organizations or multiple companies. For example, Intel, AMD, IBM, HP, Nvidia, Oracle. So multiple companies, they came together and they have formed this consortium or organization, OpenMP Architecture Review Board. And this organization is managing OpenMP API. This OpenMP follows shared memory model, as OpenMP is used to create multiple threads and these threads share the same memory space, and that's why it is said that OpenMP follows shared memory model. Now see, it is also said that OpenMP follows fork join model. What is the meaning of this? Look at this. So when we run any program which uses OpenMP, so it gets started with one thread, and that thread is called a master thread. That thread is called a master thread. So this will be the master thread. So see, there will be single thread. Now at some point we require multiple threads. So see, by using OpenMP we will create multiple threads, and all these threads are called as slave threads. Here I am writing, at some part of program we will create multiple threads, and all those threads are called as slave threads, like this. Now see, here we are using multiple threads. Those threads will run parallelly. Those will complete their tasks. Those are allocated to them, and after completion of their task they will join to the parent thread or master thread. So in the beginning we are starting with a single thread. That thread is called as the master thread. At some point, at some portion of program, we have to create multiple threads. We will divide main task into the subtasks. That subtask will be allocated to the multiple threads. Those threads will run parallelly, simultaneously, and after completion of those tasks, these threads will join to the parent thread or master thread. And that's why it is said that OpenMP follows fork join model. So that's why we are saying OpenMP follows fork join model. And as all the threads share the same memory space, we say OpenMP follows shared memory model. Now we will see how to write C or C++ program by using OpenMP. So look at this. As it is C or C++ program, we have to include one header file, omp.h. This omp.h or OpenMP API is supported by GCC and G++ compiler. In Linux operating system like Ubuntu or Fedora, we have by default support of OpenMP for GCC and G++ compiler. If we are using Windows operating system, then for GCC and G++ compiler, we have to download MinGW. See, I will show you. So look at this. In my computer, I have downloaded recent version of MinGW. Here you can see. This is a bin folder. This path we have to mention in system variables. Edit the system environment variables. So here already I have mentioned. So look at this. This is path, right? So already here I have mentioned. So I have downloaded recent version of MinGW and path of bin folder here I have mentioned, right? So if you have not done it, so here you have to add it, then click on OK or save. See, we'll check on command prompt. G++ dash version. So here you can see I am using recent version 15.1.0. So latest version of MinGW supports OpenMP. Now how to create threads in our C++ program. So see, we have to use directive #pragma omp parallel. This is the directive that we have to use. Which header file we have to use? omp.h, right? Already we have seen omp.h. That header file we have to use. And to create multiple threads, wherever we require multiple threads, There we have to use this directive hash pragma space omp space parallel. Okay, hash pragma omp parallel, and this is the block that will be executed by the multiple threads. Now see, here we have not mentioned how many threads will be created. Keep in mind, in OpenMP, by default, number of threads will be equal to the number of available processor cores. So how many processor cores are provided by your processor, those many threads will be created. So normally we have 8 cores. Okay, so if it is a 4 core processor, so 4 threads will be created. If it is 8 core processor, then 8 threads will be created. So see, every thread will run this block simultaneously. So by default, 8 threads will be created as my processor has 8 cores. So 8 threads will run simultaneously and all those threads will run this statement print hello world. We will see one example. Look at this. So look at this program. So here I have added hash pragma omp parallel, this directive. We are using header file omp.h. Here I have added printf statement. Normally, in C language, to print any output, we use printf function, right? And in C++, we use cout, right? But cout is not thread safe, and because of that, we may get some unexpected result. And because of that, though it is a C++ program, but we have to use printf function. As printf is thread safe, cout is not thread safe. That's why we have to use printf only. And as we are using printf, here we have to include header file stdio.h. Okay, now see, we'll run this. So for that, we'll open this terminal. Okay. Now see, to run any OpenMP program, so see, this is C++ program, that's why we are using tool G++, right? Now we have to use one clause dash f OpenMP like this. So this clause we have to use dash or hyphen f OpenMP. Now name of the program. So what is the name of program? OpenMP1 .cpp, right? Okay, press enter. So got compiled. Now we will run it. Okay, so look at this. How many times we got this hello world? So 1, 2, 3, 4, 5, 6, 7, 8, right? So 8 times we got hello world. Here you can see. Actually, in our program, we have written only one statement, right? But still, we got this output 8 times. Why? Because see, my processor is 8 core processor, and because of that, by default, 8 threads are launched. And because of that, this hello world statement is written 8 times. By default, there are 8 threads, and all those threads they are running this statement, and that's why we got hello world 8 times. Now see, if you want particular number of threads, so for that we have to use clause num underscore threads. In this clause, we have to mention how many threads we want. Suppose we want 7, so 7. Suppose if you want 5 threads, so here we have to mention 5. And why printf only? So already I have told. Printf is thread safe, while cout is not thread safe. That's why we have to use only printf, though it is a C++ program. Okay, now look at this. In our program, so here we'll use that clause num underscore threads. Suppose if you want 5 threads, so here we'll mention 5. We'll save it. Again, we'll compile it. Got compiled. Now we will run it. So see, now we got hello world 5 times. 1, 2, 3, 4, 5. So previously hello world got written 8 times, right? But here, as we have mentioned, number of threads, that is 5. So we got hello world 5 times as 5 threads are created. Okay, now we will have one better example for the array addition. So whenever we want to learn parallel programming, this is the best example, array addition. So look at this. We have 2 single dimensional arrays of size 5. So see, 1, 2, 3, 4, 5, that is first array, and second array is 6, 7, 8, 9, 10, right? When we have to add these 2 arrays, so how those are added? So see, 1 will get added with 6, 2 will get added with 7, 3 will get added with 8, 4 with 9, 5 with 10, right? So when we have to add 2 arrays, normally we are writing for loop. So see, when we are using for loop, so I, first iteration, I will be 0, and this 1 and 6 will be added. In second iteration, 2 and 7 will be added. In third iteration, 3 and 8 will be added, right? But see, addition of 1 and 6 is not related with the addition of 3 and 8. This addition is not related with the 5 and 10. All these additions are independent. So we can add them independently. But normally when we are using for loop, all these additions are done sequentially, right? So see, what we will do, we will take help of OpenMP. So look at this. Instead of using for loop, what we are doing, we are using this directive hash pragma omp parallel. Here we are using this clause to create 5 number of threads. Why 5 only? Because see, these arrays have size 5. That's why we are creating 5 number of threads. And all those threads will run from this to this. Now see, when these threads are created, they have some ID. And those ID is from 0 to n minus 1. As there are 5 number of threads, ID will be from 0 to 4. 0, 1, 2, 3, 4. Now see, those array indices are also similar, right? Array indices are from 0 to n minus 1. In this case, it will be from 0 to 4. So we will take advantage of thread ID. So look at this. All these threads will run from this to this, right? Now see, thread with the ID 0. What it will do? It will add A of 0 with B of 0. Addition will be saved in C of 0. Now at the same time, thread which has ID 1. So it will add A of 1 with B of 1 and result will be saved in C of 1. At the same time, another thread will add A of 2 with B of 2. Addition will be saved in C of 2. At the same time, another thread. It will add A of 3 with B of 3. Addition will be saved in C of 3. So all those addition will be done parallelly, simultaneously, concurrently. Right? So in this way we can use OpenMP for the array addition. So this one example we have taken. Similarly, we can use OpenMP for another cases. Right? Look at this. Same program here I have written. Look at this. It is the same program. Right? We will run it. G++ yep, OpenMP. Our program name is OpenMP2.cpp. Right? Enter. Okay, so here you can see, here we got the output, right? But see, here we got C of 4 first, then C of 1, then C of 0, then C of 2, C of 3. Because see, we have launched 5 threads and all these threads are running simultaneously. So we can get output in any sequence. Let's see. Again, if we run it, so now here you can see. Now we got the result, but in another order, right? Previously C of 4 was first result, but here we got C of 2. That was the first result in this case, right? So all these 5 threads, they are running simultaneously, and whatever the threads those have completed the task first, we will get that output. Okay, so in this way we can compile program and also we can run it. If we want to give another name to our executable file, so see, we can use this clause -o. Here we can give name of the executable file, and by that name we can run that program. So by default name of the executable file is A, and also we can give our own name by using clause -o. We can also use OpenMP with for loop. So see, look at this. This is normal for loop, right? When we are not using this statement, so what will happen? See, this for loop will run sequentially. Initially I will be 0, it will execute this statement, right? First iteration. Then I will be 1, another iteration. Then I will be 2, next iteration. And all these iterations will be sequentially. We can parallelize this for loop. What is the meaning of that? All those iterations will run simultaneously. Look at this. Here we are using directive hash pragma omp parallel to create multiple threads. As we are using for loop, here we have to mention for. Right? Now see all these iterations. Here in this case we have 6 iterations. So all these iterations will run parallelly, simultaneously. Look at this. Same program. See, same program. Here we are writing it by using for loop. So see, here we have mentioned for hash pragma omp parallel to create a multiple threads. As we are using for the for loop, for. And here in this case we have to create 5 number of threads. That's why num underscore threads 5. Right? See, this function omp underscore get underscore thread underscore num, it is used to return thread id. So look at this. In this for loop we have 5 iterations, and all the 5 iterations will run parallelly by using 5 threads. Okay, we will run this. So our program name is OpenMP3. Okay, now we will run it. So here you can see same result we got. See again, if we run it, so see in some another order, but same result we got. So in this way we can use OpenMP for creating multiple threads in C++ programming language. This Word file and programs I will share in my Udemy course. You can download them from the resources. Okay, so we will meet in next video. Thank you.